Concentrations of solutions can be expressed in many ways such as molality, molarity, normality, formality, mole fraction, etc. Let us do some calculations based on the concentration terms. The first problem is given here as if 5.6 gram of KOH is present in 500 ml of the solution and 1 liter of the solution, calculate molarity. Here two problems are given here, is it not? What is the molarity of the solution containing 5.6 gram of KOH in 500 ml of the solution? This is one problem. Then what is the molarity of KOH present in 1 liter of the solution? Now let us do one by one. How to calculate molarity? Molarity is denoted by the letter capital M. The formula to calculate molarity is number of moles of solute, divided by volume of the solution in liter. Volume of the solution, the volume should be given in liter, volume of the solution in liter. Now, what is number of moles? Number of moles N is equal to, number of moles is given by the letter N. This N is equal to mass by molar mass, mass by molar mass. Now what is in our question? What is the molarity of the solution containing 5.6 gram of KOH in 500 ml of the solution? First calculate the number of moles. Number of moles is equal to mass by molar mass. Mass is given as 5.6 gram in our problem, is it not? 5.6 gram divided by what is the molar mass of potassium hydroxide? Formula for potassium hydroxide, KOH. How to calculate molar mass? In your earlier classes you studied as mass of potassium is 39, mass of oxygen 16 and mass of hydrogen is 1. The total of these mass will give you the molar mass of KOH. So, the total is 56. So, molar mass is 56. If you divide 5.6 by 56, what will be the answer? Yes, it is equal to 0.1. This is the number of moles of 5.6 gram of potassium hydroxide. So, substitute in this molarity equation. Molarity is equal to number of moles 0.1 divided by volume of solution. In our first problem, it is given as 500 ml, but the volume should be given in liter. 500 ml of solution is equal to 0.5 liter, is it not? It is half of the liter. So, 0.5 liter. Note here, the volume should be given in liter. So, 0.1 divided by 0.5 will give you the answer 1 by 5, that is 0.2 m. 0.2 m. This is the molarity of 500 ml solution containing 5.6 gram of KOH. Then our next problem, this is for A, answer for A, and for B. Again number of moles is 0.1 only. So, you can substitute this here, 0.1 moles are present in 1 liter of the solution. Here volume of the solution should be in liter. So, it is equal to 1, the answer of which is 0.1 divided by 1, that is 0.1 m. So, 0.2 m is the molarity of the solution containing 5.6 gram of KOH in 500 ml. 0.1 m is the molarity of the solution containing 5.6 gram of KOH in 1 liter of the solution. Now, let us see the next problem. 2.82 gram of glucose is dissolved in 30 gram of water. Calculate the mole fraction of glucose and water. How to calculate mole fraction? Mole fraction is given by the formula. Mole fraction is equal to number of moles of the component divided by total number of moles of all the components. Number of moles of the component divided by total number of moles of all the components. Here what are the components? All the components means this solution contains two components. One is glucose and another one is water. So, two components are here. Now, let us calculate the number of moles for the components individually. So, number of moles, you know the formula, mass by molar mass. So, number of moles of glucose. Do you know the formula for glucose? C6H12O6. Number of moles of glucose is equal to mass of glucose. What is the mass given? 2.82 gram divided by what is the molar mass of glucose. As you calculated already for KOH, here also you can calculate the molar mass for glucose. The formula is C6, mass of carbon is 12, you know. So, 6 carbon atoms with the mass of 12, 12 hydrogen atoms with the mass of 1 and 6 oxygen atoms with the mass of 16. So, multiply these values, 6 into 12, 72, 12 into 1, 12, then 6 into 16, 96, add all these values, 0, 180 is the molar mass of glucose. So, mass is given as 2.82 and molar mass is given as 180. So, if you divide this 2.82 divided by 180, the answer will be 0.016. This is the number of moles of glucose. Then what is the number of moles of water? Number of moles of water. Molecular formula you know already, H2O. To obtain the number of moles of water, we have to apply the value of mass of water. What is the mass of water here? 30 gram divided by molar mass of water. Yes, you know it clearly, it is 18. So, if 30 is divided by 18, the answer will be 1.67. This is the number of moles of glucose and this one is number of moles of water. If you add these two numbers, you will get the total number of moles of all the components, isn't it? So, add these two values, total number of moles will be 1.67 6. Am I right? Okay. Now apply these values in this equation. Now mole fraction of glucose is equal to number of moles of glucose divided by total number of moles of glucose. Similarly, mole fraction of water is equal to number of moles of water divided by total number of moles of water. Let us calculate first for water. Mole fraction of water is equal to, what is the number of moles of water? 1.67 divided by, what is the total number of moles of all the components? It is 1.686. 1.686. So what will be the answer here? It is equal to 0.99. This is the mole fraction of water. What is the mole fraction of glucose? I told you already, it can be calculated in two methods. Either by dividing the number of moles of glucose divided by total number of mole, or you can subtract the value of mole fraction of water from 1, because in any solution, if you add the mole fraction of all the components, it will be equal to 1. So, mole fraction of glucose C6H12O6 is equal to 1 minus mole fraction of water. Yes, apply the value. 1 minus mole fraction of water is 0.99, that is equal to 0.01. This is the mole fraction of glucose. So, this mole fraction can be calculated by subtracting from the value of 1. So, mole fraction of all the components when added, it will be equal to 1. Now, let us do some more calculations. Similarly, the next problem is given as iodopovidone antiseptic contains 10% W by V, that is weight per volume of iodopovidone. Actually, iodopovidone is an antiseptic solution. This contains 10% W by V of iodopovidone. Calculate the amount of iodopovidone in 1.5 ml of a typical dose. Now, what is the meaning for 10% W by V? 10% means 10 by 100. This indicates what? 10 by 100 W by V, that is 10 gram of iodopovidone is dissolved in 100 ml of the solution. So, our question is, what is the amount of iodopovidone in 1.5 ml? We know 100 ml contains 10 gram. What is the amount in 1.5 ml? 10 divided by 100? Yes, it is equal to 1 by 10 into 1.5. The unit will be in gram. So, what is the value of 1 into 1.5 divided by 10? It is equal to 0.15 gram. Am I right? So, this is very simple problem. 100 ml of the solution contains 10 gram. So, 1.5 ml of the solution contains 0.15 gram. Right. What is the next problem? A liter of seawater weighing about 1.05 kilogram contains 5 milligram of dissolved oxygen. The seawater contains 5 milligram of dissolved oxygen in it. Express the concentration of oxygen, dissolved oxygen in ppm. ppm means parts per million. Parts per million. So, the formula for calculation of ppm, parts per million is equal to mass of solute divided by mass of solvent. Tell me, what is the solute here? Solute is dissolved oxygen. What is the mass of dissolved oxygen? 5 milligram. So, ppm is equal to, sorry, I left here. This should be given for parts per million. So, it should be multiplied by 10 power 6. So, ppm is equal to mass of solute, that is 5 milligram of solute is dissolved in mass of solvent. It is given as 1.05 kilogram. So, 1.05 kilogram into 10 power 6. Here mass of solute is given in milligram, mass of solvent is given in kilogram. Convert all these things to gram unit. So, now ppm is equal to 5 milligram is equal to how many grams? 5 into 10 power minus 3 gram, is it not? Milligram when converted into gram, it should be multiplied by 10 power minus 3 divided by 1.05 kilogram. You know 1 kilogram is equal to 1000 grams, is it not? So, 1.05 into, you can write it as 1000 or 10 power 3. So, here 10 power 3. So, now all are converted into gram unit. Into what? Yes, into 10 power 6. Do the calculation now. ppm is equal to 5 divided by 1.05 into, here it is 10 power minus 3. If you bring the 10 power 3 in denominator to the numerator, it will become 10 power minus 3. So, again 10 power minus 3. You already have here 10 power 6. So, 10 power minus 3 into 10 power minus 3 will become 10 power minus 6. We have 10 power plus 6 here. So, we can cancel this 10 power plus 6 for this 10 power minus 6. So, now the answer is 5 divided by 1.05, which will be equal to 4.76 ppm. So, this is the answer for this problem. So, by knowing the simple formulas like this, you can calculate the concentration of solutions in any unit.